So, today in this session we are going to learn about optical instruments and the diseases of eyes, how we use specs and how specs are used to correct our vision. So, for all these discussions we require some basic knowledge of the working of our eye. So, a small discussion on the physiology of human eye, that is the working of our human eye. So, our human eye is something like this, with this somewhat spherical, and here you see this is the bulging part which we see from outside, we call this cornea. Here there is a lens, this is our lens here, this is a crystalline lens which is held by some muscles. These are crystalline lens which is held by some muscles. So, these are muscle fibers which held this. So, there is a shutter here, we call this iris. So, this controls, this is a screen type things which can contract and open, it can dilate. So, when there is more light, then it contracts and allows less light to come inside it, and when it is darkness, these pupils contract, dilate, so allowing more light to come inside it. So, this is the screen stop in place of this crystalline lens. Here is some liquid, and here the liquid is called aqueous humor, here vitreous humor. So, this is the optic axis of the eye. Now, here there are optical fibers, here there are some fibers which passes the signal to the brain for processing. So, we have, this is called retina. Now, on the retina there are different cells, different types of cells called rod cells or cone cells. Rod cells and cone cells, they work for different conditions. One type of cell works for bright light and one type of cell works for dim light. So, at night cone cells, rod cells are working, and in the day when the light is bright, our cone cells might be working. That is the detailed biology of that we can find in the detailed biology of this. So, presently we are interested in, this is the lens which is controlled by some muscles here. So, under normal conditions what happens, the muscles are relaxed and converges a parallel beam of light on the retina. So, this is under normal conditions, but when we want to seek a close by object, nearby object, that means if this is my object, then this object has to be focused. So, what happens in that case, if you have to see a nearby object, then we have to, these muscles will get contracted, they will get contracted, and they will, due to this contraction, then the lens will get modified, the lens structure this gets modified, and thus this object is brought into focus. So, the process of adjusting the focal length of the lens by applying some contraction here in the muscles, this process is called accommodation. That means our human eye, the focal length of the human eye is not fixed, it can change depending on what object we want to see. Our eye is highly relaxed if we see a distant objects, but when we see a nearby object, then it gets accommodated. So, this is how our eye works. So, let us see what is accommodation first. Now, let us come to what is accommodation. So, it is the process by virtue of which the human eye modifies its focal length to bring in focus the desired object. The disease in which the eye loses its power to accommodate that is called presbyopia. So this is what accommodation is. Now you see, this is our human eye and this is our lens, eye lens. Suppose we bring two parallel rays, so they are focused on the retina and the eye is here relaxed. So we see a distant object like this. So eye is relaxed and unaccommodated eye, normal eye. This is how we see a distant object. You see this lens, eye lens. Now when this is the optic axis, when we see a object which is at a very close distance, then the rays goes like this, and you see here the lens get modified, and so this object is brought into focus. So when we are seeing a close by object, when we are seeing a object very near to us, then our eye lens gets modified, strained, the muscles here get contracted, the muscles are contracted here and here they are relaxed, here the muscles are relaxed, contracted, we strain our eye. So when we are seeing a close by object, when I see a close by object, I am straining my eye muscles, and so fully accommodated eye. That means we can see objects as far as infinity and as close as where I can accommodate my eyes maximum. So if I have done maximum accommodation, so the nearest point which I can see will be called least distance of distinct vision, D. That is called the near point. Please take this note. So now near point, it is the point which is closest to the eye at which the object placed can be seen clearly, distinctly. This is called near point. The eye is highly accommodated in this condition. This is called near point, or this point is also called least distance of distinct vision. And this will be that distance D, that point will be named D by us, and that distance is assumed to be 25 centimeter for a normal adult. You see, this distance for infants can be as close as 5 to 6 centimeter. So 5 to 6 centimeter means this much size, and for infants they can see objects clearly at a very short distance of 5 to 6 centimeter, and for teenagers, college students and teenagers, this can be 15 to 16 centimeter, 10 centimeter to 15 centimeter, 18 centimeter. For a healthy adult, this point is taken as 25 centimeter. You see, the eye is most strained, fully accommodated when the object is placed at the near point or least distance of distinct vision. Now, if I bring an object here, then my lens cannot further modify itself to bring in the focus on the retina. So, we can't see the objects near before least distance of distinct vision, we will get a blur picture. The least distance of distinct vision for a normal adult is taken as 25 cm. Therefore, it is advised for us to read anything kept at a distance of a feet or 25 centimeter, this distance. This is the advised distance because the least distinct of distinct vision is 25 cm. Next is far point. Next point is far point. What is the farthest object which can be clearly seen? So, for a normal eye, the farthest far point is infinity, because we can see distant objects as distant as stars, sun, moons, heavenly objects. They are at infinite distance. So, that is called far point. So, it should not have a special mention. Simply the far point for a normal person is infinity, we can see. But for some diseased person, they can't see distant objects very clearly. So, their far point is not infinity and somewhere 2 meter, 3 meter or something like that. So, in that case far point becomes important for them. We will see later on. Now, come to the condition of a defect of vision, that is called nearsightedness or myopia, which is very common among teenagers. The diseased eye in this condition focuses the parallel rays in front of the retina. As a result, the distant objects appears blurred to the person. The person can see the nearby objects very well. So, it very well. So, what happens whenever any object is far away, the person tries to bring that object close to its eye and then he can see it very well. So, nearsightedness means the diseased person goes very near to the object to see the object. That is why its name nearsightedness, and it is also called myopia. So, what happens in this disease? Suppose now this is the diseased eye and this is your far point for this person. That means the person under relaxed condition of its eye is able to see this. So, this is far point, this is myopic far point, let us call this MFB, myopic far point. And suppose the person wants to see a nearby object, so you see this is highly accommodated, so the person, it is myopic near point. So you see this is the vision, this is unaccommodated myopic eye, and this is fully accommodated myopic eye. So you see the what happens in this disease. So here the eye lens is relaxed, the eye muscles are relaxed. So when it is relaxed, then a normal eye means the parallel rays will be focused, but we have seen that the parallel rays are focused here only. So this is the myopic far point. So this is the farthest point which can be focused, and this is myopic near point. That means when the eye is fully accommodated, then the person, diseased person, can see this. That means the diseased eye, the vision of diseased eye is between myopic far point and myopic near point. So this, if anything is kept in this, then the diseased eye can see it very clearly. So distant objects cannot be seen. So you see normal eye has a image vision from near point, normal near point of least distance of distinct vision to infinity, but his vision is confined within this distance. So this is what happens in myopia. Now what we have to do is, I have to bring this myopic far point to infinity, and if it is corrected, we can see how it can be corrected. So this is the condition, diseased condition. The disease can be corrected by using diverging lens. One more point, actually we cannot correct the disease, but the vision is corrected. Vision is corrected means, now you see this is my eye, and what we do, we suggest the person to use a diverging lens with negative power. Diverging lens has a negative power. So what is the role of this diverging lens? This is your myopic far point. This is the farthest thing. So what if we are seeing a distant objects, we are seeing the distant object by using specs, the diseased person. So what it will do, it will diverge it, it will diverge it. So suppose lens is up to here, so it will diverge this lens such that the object at infinity is, suppose, seems to be coming from here. So our eye thinks that the object is at its far point, so it is able to focus it. You see, this diseased eye can focus this myopic far point to here. So with this specs, we are able to put this parallel beam in such a way that eye is thinking that the object is here, and so this eye can focus it on this spot. So thus it is, so unaccommodated myopic eye with correction. With correction means specs we have used it. This is fully accommodated, and suppose this is the normal near point, least distance of distinct vision. Let us call this point as normal near point. This is normal near point, and this is your myopic near point. So what happens? This lens not only corrects this point, but suppose we have, so you see the ray gets diverged so that it seems to be coming from this point. So this ray can be focused here. So our eye has the capability to accommodate all the points on myopic near point. So this is fully accommodated myopic eye with correction. So what we see, if anything kept at normal near point, we are befooling the eye that it is at this point. Which point? Myopic near point. So although my eye is only seeing within this distance, but with the help of this eye plus this lens, we have brought this point to normal near point and its far point to infinity. So what I have done, the power of diseased eye plus power of lens becomes equal to the power of a normal eye. So this is what we have to do, and by using this type of specs, how its near point is also corrected, how its far point is corrected. Now next common disease is of eye is farsightedness, hyperopia. Now in this condition, the rays parallel to the optic axis are focused beyond the retina. So we get a blurred image. It is corrected by using convex lens that has positive power. Now what happens in the disease? First see, this is the normal position. Under normal conditions, the parallel rays are focused beyond the retina. So distant objects will appear blurred for these people. Now suppose when the diseased eye is highly accommodated, then what happens? Then it is able to suppose focus this. So this is hyperopic near point. So unaccommodated hyperopic eye. This is fully accommodated hyperopic eye. So for this person, this distance becomes very large. This is suppose normal near point. So this is 25 centimeter. The person's hyperopic near point has moved to 1 meter. The person will, if given any book to read, the person will read like this. It will keep the distance. So the normal 1 feet distance of near point increases to 1 meter. This is what happening here. So, the person, whenever anything is given, he wants to put the things far away to see it clearly. So, we say that it is far-sightedness, means from a large distance the person wants to see things clearly. So, it's what is the disease? The far point has moved beyond this distance to a large distance. So, this is the disease. Now, the diseased person is asked to use a converging lens, convex lens with positive power. Let us see how this condition can be cured by using a convex lens. Now, let us see that this is my diseased eye and this is the, we are using the lens under normal adjustment, means my eye is relaxed position. So, this is unaccommodated hyperopic eye with correction. What is the correction? We have used a converging lens, suppose. So, what happens? This is the parallel ray, this parallel ray bends this, and now we are not getting here parallel rays, we are getting a convergent beam which can be converged by this lens. So, thus distant objects can be seen. Now, you can see here, you see what happens if parallel rays are there, they are focused here. So, there will be some rays which can be focused also. So, what happens in a diseased eye? This is the diseased eye, and suppose a ray is there like this. That means if we give a convergent beam, then the diseased eye without accommodation can be done like this, can focus this. So, what we do with the help of this, we give this convergent beam. So, you see this beam, convergent beam can be focused here. So, we have brought this parallel rays into convergent beam that can be focused by the diseased eye. Now, next case, when my eye is fully accommodated. So, it is fully accommodated hyperopic eye with correction. That means we are using a lens also. So, what happens? You see, this is my hyperopic near point and this is the normal near point. So, any ray here going like this will bend like this, such that if it comes, it seems to be coming from the hyperopic near point, then this with full accommodation can be focused on the retina. So, the diseased eye, this lens fools the eye by telling that the object is here, but actually object has been placed here. So, in this way, this hyperopic near point has been brought to this location, and now you can see the distant objects and your vision is now between this to infinity. With the correction, now you can see from normal near point to infinity, and thus this disease can be, the vision can be corrected. We don't cure the disease, we try to make the power of the diseased eye plus extra lens equal to the power of a normal eye. This is what we do in the disease with the specs.